So hey guys, today we're going to talk about Quicksort. As you all know, Quicksort is an algorithm that is based upon divide and conquer technique. And in Quicksort, essentially what we do, we'll partition the array into the left and the right subarray on the using pivot as the basis for partition. And as we know, first to implement Quicksort, we first have to find the pivot as and I will show you how to do implement Quicksort in Java. Suppose we to sort that element, first we have to find the pivot. First we have to find the pivot. First we have to find the pivot. Pardon my writing. So how do we find the pivot element in this array? To find the pivot, we'll take two counters, low and high. Low and high in our array, unsorted array. Using these low and high indexes, we'll find the index. We'll take the middle. We'll create a new variable mid, and as you can see in the code, we have created a new variable mid, and using this mid, we have found the pivot element in the array. So now we have got our pivot element, and in this array it will 0 1 2 3 4 0 plus 4 by 2 array. At the second position we have our pivot element. So now we have found our pivot. We have our left and low and high pointers, left and right low and high pointers, whatever you can say. The next step is to traverse the array until its end, and while we are traversing this array, we have to compare the element in the we have to traverse this array. We partition the array into the two subarrays. So those two subarrays would be left subarray and the right subarray. So how the left subarray and the right subarray are constituted? So the left subarray and right subarray is partitioned on the basis of pivot, so that the elements less than the pivot are on the left hand side, and the elements greater than the pivot are on the right hand side. And in this both of these while loop will keep on incrementing. We'll take a counter I and j here. We'll keep on incrementing this and decrementing this. We'll keep on incrementing this and decrementing this until they reach less than pivot. Now while we are executing these conditions, we can arrive at a condition where an element could be greater than pivot. Suppose this is the element. Our first element is greater than pivot element. So this loop will be exited, and we'll move on to this. Now this condition evaluates that whether our I is still less than j. It goes for index I. This is a condition whenever, suppose if the elements in this left subarray are greater than the pivot, we want to check that whether they have traversed until less than pivot or not. They have traversed up through pivot, that means they are greater than pivot, or they are less than the pivots. If they are less than the pivot, then this condition will come in handy. That means our first element is greater than pivot, so this loop exits, but our j is still greater than pivot, that means j will continue. But at this point of time, I is 1 and j will decrement. It will become 0 1 2 3, but it is still greater than I. That means this condition will execute. So using this condition, we'll transfer the bigger array to this side and take the j variable and store it in the ith position. So this loop will keep on executing until both of these elements have reached a condition where our I has gone above pivot and our j has come down to the elements, down to a subarray that are less than pivot. So in this condition we have both the elements, we have our subarray arranged in both the elements, and we are going to whenever after the execution of this condition perfectly and these loops are executed, now we have two subarrays, two partitioned subarrays. So the left subarray would be here, right subarray would be here, and in between we have our pivot, left subarray, right subarray. Now we also have, at the end we have to join all of them to get our sorted array. Now inside the left and right subarray there may be elements that are greater than the other elements, and in the right subarray there may be element that is smaller than the other elements. So we have to sort this left and right subarray in itself. To sort them we use recursion. We'll take our left variable, left pointer is still, there is a right pointer. So we'll take our left subarray and right subarray and sort them. Where is our left subarray? Our left subarray start from L, our low, go up till J, right, and then we have the next, our right subarray go from I until R right, and in this position we're going to call our function recursively to keep on sorting in itself. Now after the execution of this condition, when all of the elements are sorted, left and right subarray are sorted, we call that function here. So now after the end of this function, it will return and it will return us the sorted subarray, which would be 3, 4, 5, 7, 8. Now this is our sorted array that we'll get at the end. Okay, thank you. So now what we have, now next step would be to call an array. This is our array, and we'll use loops to traverse through the array before calling our quicksort function and after calling our quicksort function, as you can see here. Now if I just run this program, as you can see in the output screen, and before sorting these are the elements, and after sorting you can see all of the elements are in perfect order. So that's it guys, this is quicksort, and that's how you can do this by, and I hope that you guys have understood this. So now it's time to solve a HackerRank problem. So this is a HackerRank problem on quicksort, and in this HackerRank problem we are given that we give an array and we have to sort it using quicksort. And you can also use this explanation to reinforce your understanding that you have built through the video explained earlier. In this video they are given that this is the array, we have found pivot, and we're partitioning into 3 parts. One is left, second is pivot, third is right, settle that we done and all the stuff. Now we are given an unsorted array, we have to sort it, and this is the definition or the principle that the quicksort is based upon is given. So now what we're going to do here is, this is the code, yes, I've already done it. So in this we are not given our low and high pointers, so that's not a problem. We'll just create another function that will call quicksort, and it will return an sorted array. So we can return this array. So this return array would be called when we create another function called quicksort, and we'll pass it in here the array, the left pointer and the right pointer. So So now we create another function, static void quicksort. In this, an array, left pointer, right pointer. Now our first step would be to find the mid. How will we do that? We'll take left plus right division by 2. Now our second step would be mid. Our second step would be to store our variables, another variables, int I left and int j equals right. Now the reason that we're doing here is because our original pointers will help us at the end in comparison at the end for the left and the right subarrays when we're doing sorting of the left and the right subarrays, so that we do not want left and right pointer values to be affected. So that's why we're storing it in I and j value. So now next step is to find pivot. How do we find pivot? We'll just return middle element. We already found the middle element. We just return the middle element. Whatever the element is in the array, that becomes a pivot. So the next step after pivot is traverse the array. I'll traverse the array. Will start from left pointer, go until right. So and in this loop will go on until the whole we traverse the whole array, and inside the loop we are partitioning our array into subarrays. First partition will be where our element in the left subarray is less than pivot element, and until this condition is true, we're going to increment our left counter, and same for the right subarray greater than pivot. We're going to decrement until it is less than pivot. So both of these loops follow the principle on which quicksort is based, where the elements less than the pivot goes on to the left hand side, and elements greater than the pivot goes on to the right hand side. So now after the whole traversal is going on, there can be a condition where, as explained in example, there can be a condition where while traversing the elements, we can get an element on the left hand subarray which is greater than the pivot. Suppose we start from here, we get an element at the first position which is greater than the pivot element. So in that condition, the loop that we have here, it will terminate at that instant only. So if the loop terminates at that instant only, we're going to have a problem, because if we check the next loop, j is perfect. Here is I, here is j is perfectly obeying the condition. Now j has come here. Now if that condition executes, we're not going to if the I exits this loop, we're not going to get our left sorted subarrays. So there will be problems to the left hand side of the subarrays. So to counter this problem, if our I is less than j, we're going to swap the position of array I and j with each other. Array I equals array j, and array j will be at the position of array I. So the reason that we're doing here is that there can be elements in the array, in both elements in both sides of the array, which do not fulfill these conditions. And suppose if 3 was here instead of this, we could get both of our left and right pointers exiting this loop. So if this type of condition arise, we want to swap those both elements so that we can maintain the consistency of our database. So for this reason, what we're going to do here is, so to maintain the consistency, we'll swap those elements. So 5 is swapped by 3, so now our array will be 3, 7, 4, 5 and 8. So now as you can see, the our array is taking the shape of somewhat sorted array in these places. So now the next condition, when we move our I here again, we'll find that again our pivot is less than our element, and j is here less than pivot. Now j is at pivot element because j is fulfilling the conditions. Now we'll swap both I and j. So now our array will become 3, 4, 7, 5, 8. Now at this condition, I is here at pivot, j here, I is still less than j, I is less than j, this condition will fall. So now our left array is sorted, subarray is sorted. Now we have to sort the right subarray. To do that, and in this array, if we found that all of these our while loops are properly executed, this condition will not be true. Now we move on to these two conditions where we have elements on the left hand side of our subarray and we have elements on our right hand side of our subarray. So there must, in this condition, there can exist some elements where in the left or right subarray will still have the unsorted elements. To sort this, we'll call the function recursively and take start and end. And at this point of time, when all of these conditions are executing, when we move on to this condition, our I pointer has already crossed pivot and our j pointer, means our right pointer, is at the left subarray. So this and the original our left and right pointers are here. So when we have to sort left and right subarray, we'll have to put those put where the left and the right subarray start and end. So our left subarray will start from left pointer to j pointer, right subarray will start from I to right pointer, and the same I have put in the quicksort function. Will start from left, go until j, and sort the elements on left subarray, and will go from I till right, sort the right hand subarray. And when all of these execution are instruction properly executed, in the end we'll get our sorted subarray, sorted array which are combined then to give us a sorted array, which will be 3, 4, 5, 7 and 8. So this is what we'll get in the result. So now coming back to HackerRank question, we'll have this condition now. If our left pointer is less than j, because j will come at right hand side when these conditions are not executed properly, will call our function recursively and pass it in the values start and start from left pointer, go until j. It will sort a left subarray, and if our I less than right, a pointer less than the right pointer, it will sort our right subarray, same start from I, go until right pointer. Now while all of these conditions are properly executed, it will sort our array. It will sort the unsorted elements into sorted elements and return a sorted array. Now here's the problem. Oh yes, We also have to increment and decrement subsequently both of the pointers. Now it will run. So this is the condition that was producing the error. Now it's success. Now we just submit code to see that does our code passed all our test cases. Yes, as you can see, our code passed all of our test cases. So guys, this is Quicksort, and I hope you understand all of and this is Quicksort, and I hope you understand what I was saying. This is just a simple question, nothing more. You just have to understand what is happening at and what inside is happening, and consider the edge cases, and you can easily do it. So guys, if you like this video, please give it a thumbs up and subscribe, and if you have any suggestions or comments, please write them down in the comments.